Guys, welcome back to TechDose, and in this video we will look at reschedule meetings for maximum free time 2 problem, which is from Leetcode number 3440. A good problem to solve after having solved this is 3439, which is the first part of this given problem. Let's now read the problem statement. You are given an integer event time denoting the duration of an event. You are also given two integer arrays start time and end time, each of length n. These represent the start and end times of n non-overlapping meetings that occur during the event between the time t equals to 0 to t equals to event time, where the ith meeting occurs during the time start time at I, end time I. You can reschedule at most one meeting by moving its start time while maintaining the same duration, such that the meetings remain non-overlapping. To maximize the longest continuous period of free time during the event, return the maximum amount of free time possible after rearranging the meetings. Note that the meetings cannot be rescheduled to a time outside the event and they should remain non-overlapping. And we should also note that in this version, it is valid for the relative ordering of the meetings to change after rescheduling one meeting, because this was not allowed in the first part of the problem. Okay. Now let's look at an example. In this case, the event time is 5 and the start time is always 0 as mentioned. So there are two meetings, one meeting starting at 1 and ending at 2, another meeting starting at 3 and ending at 5. If you try to reschedule this first meeting, then where will you reschedule it to? There are only two slots available, S1 and S2. Now the width of this meeting is 1, so it can be put in either slot 1 or slot 2 by just sliding it. And if you slide it to, let's say, S2, then it will be occupying this space, and so the free time will be 2, and that is the maximum time that you will be getting. Now if you look at the second example, then in this case the diagram is already given, and if you try to consider the two slots which are mentioned, S1 and S2, because on the right hand side of 10 there is no space since the event time is 10. You can try to place this meeting A in slot S1. But if you put it in slot S1, like let's say you put A here at the end, then the space created will be 6 only. But you could have chosen another slot for A, like let's say S2, so that it will fit here because the space is allowing it to do so. And so the space created will now be 7. So if you make such kind of choice, then you will get the maximum free time, maximum contiguous free time. Okay. And similarly, you can also look at the third example. In this case, if you take this C and take it out and place it in slot number 1, will it be possible? Yes, because the width is 1 and here the width is 2. So it will be possible. And so the free space that you create is 9 minus 4, which is equals to 5. But is this the maximum space? No. What you can do is you can take this B and place it in this slot. Okay, will it be allowed? Yes, because the gap here is 1 and the width of this is 1 as well. So if you place here B, then the free space created will be 7 minus 1, which is 6. And this is the maximum space, right? So you can try out all the possibilities, and I will be showing that to you in the example. Now, in this example, there is no free space. As you can see that there will be continuous meetings from 0 to 1, 1 to 2 to 3 to 4 and to 5 as well. All the continuous meeting without any free space. So where will you reschedule it to? Because the start is 0 and the event time is also 5. So there is no free slot, and therefore the free time will be 0. If you look at the constraint, then the event time maximum value is 10 to the power of 9. So event time is the end of the timeline and 0 is always the start of the timeline. The start time dot length is equals to end time dot length, which indicates that if you are looking at index 0 on both of them, then this is the 0th meeting, start point is 0 and end point is 1, right? N value here shows the number of meetings, which is 10 to the power of 5. Start time at I is less than end time at I. This means that at least the meeting width is 1, at least. Because if it would have been 0, then here it would be written as less than equals to. So by the statement of less than, since we are dealing every time with an integer, the width of a meeting will be minimum 1, and the meeting's start point can be 0 and the end time can be event time. So we are dealing with the time range of 0 to event time. end time at I is less than equals to start time at I plus 1, indicating that there are no overlaps. Okay, if this is something which is given as 2 E2, then there is an overlap here, but due to the constraint mentioned, end time at I less than equals to start time at I plus 1, there is no overlap. Okay, so just by looking at the number of meetings 10 to the power of 5, you can make sure that n square algorithm will not pass, because that will be 10 to the power of 10, and we know that 10 to the power 8 computations is taken as 1 second, and we have to write an algorithm which runs within 1 second. So the best you can do is around n log n, and if you can even improve beyond this point, it will be even better, but n log n will pass. Okay, so just by looking at the expectation of time complexity, you can think about appropriate data structures and algorithms. I hope you have understood the problem and constraint. Let's now look at some observations. In this case, a meeting can be rescheduled anywhere provided it remains non-overlapping as it is mentioned in the problem, right? Now, the goal of the problem is to create the maximum free time. Okay, maximum free time. And this maximum free time have to be contiguous. That means they have to be in the same stretch. If you want to do that, then the problem is asking about rescheduling the meetings, and the reschedule must happen in a non-overlapping fashion. Now, if I think about rescheduling, let's say meeting A, if I take out this meeting A altogether, then S1 and S2 will combine together. S1 and S2 will combine together, and the free space will be 8 minus 0, which will be 8. Okay, and as S1 S2 will combine together along with whatever was the meeting duration of this A. Okay, this will only happen if A can be taken out and A can be placed somewhere else in some other slot except for the two adjacent slots. Then only that can happen. If let's say that A's width is higher, and it cannot be accommodated in S3, S4 or S5, then it has to be only slided either to the right hand side or to the left hand side. So you can choose to slide it in any direction, and if you do that, then let's say I slide it to the right hand side, then the space created will only be S1 plus S2. Only be S1 plus S2. It cannot be S1 plus S2 plus the width, because the width of the meeting will only get added if it is accommodated in some non-adjacent slots. Okay, so I hope this point is clear. So in this case, if you take the example of B, then B can go to any slot except for S4, because S4 slot is very small, its width is only 1 and the width of B is 2. So if you try to place B, then first of all I will try to avoid the adjacent slot S2 and S3, and I will try to consider, is there any non-adjacent slot where I can place B, so that I can maximize this slot width. So what I have to do to get the maximum free time, I have to try to reschedule each of the meeting one by one, because I can reschedule only one meeting at any point of time, isn't it? In the problem it is allowed that only one meeting will be rescheduled. So try to reschedule this A to a non-adjacent slot if possible. If not possible, then just slide it in the adjacent slot itself, and try to see what is the maximum free time that you get by combining this slots. Okay, then do the same for B, do the same for C, do the same for D, and then keep track of the maximum free time. That is how we will be solving the problem. So this is the idea. If B goes to, let's say, S1 or S5, it creates more free space, as you know, because if it goes to non-adjacent slot, then it will create more free space. Therefore, we will always try avoiding the adjacent slot. But if the non-adjacent slots are all smaller, then use the adjacent slot, as I have mentioned. So this is one example where the width of this B is 2. And if you consider the width of S1 is 1, S4 is 1, S5 is also 1. So B cannot be put in any non-adjacent slots. So it has to be just slided in the same adjacent slot. So you can slide left or right, it will not matter. Let's slide it to the left hand side, and so the free time which gets created will be 15 minus if you slide it to the left hand side, then the width will get added here. So 15 minus 5, which will be 10. Okay, and we have to repeat this for all the meetings. So I hope the observation is clear. Now let's look at the rescheduling strategy. As you already know that if we take a meeting C and try to reschedule it, then I will try to avoid the adjacent slots to maximize my free time after rescheduling C. Okay, so if I do that, then I have to find a non-adjacent slot which is able to accommodate the meeting C. Meeting C width is 1 and can it be accommodated by either S1, S2 or S5? Yes, it can be actually accommodated by all of them, and therefore the free time that gets created after removal of this C, that means rescheduling of C somewhere else to non-adjacent slot, will be S3 plus S4 plus the width of this C. And you can actually calculate it by doing start time of this meeting D minus the end time of this meeting B. That means 17 minus 9. That is how you can calculate it. But if you think it might have so happened that the width of C was very high, and in that case it would not have been possible to be accommodated by any of the non-adjacent slot, and so I would have just slided it in the adjacent slots, right? So adjacent slots are the last choice. Okay, so how do we track which slot should a meeting go to? If I think about where should this C go to, you think about the non-adjacent slot, and I can put in any of the non-adjacent slot, but in order to just optimize my number of comparisons, will I be choosing from the smallest slot? No, it does not make sense. You just take the maximum of the non-adjacent slot and that should be absolutely fine. If the maximum sized non-adjacent slot cannot accommodate C, then none of the non-adjacent slot will be able to accommodate C, right? It will not be possible. Okay, so I will be maintaining the maximum of the non-adjacent slot. And what about the adjacent slots? The adjacent slots can also come in the maximum, but because if I just consider S1, S2, S3, S4 and S5 and take the max of all these values, then you can end up getting either S3 or S4. It may happen, you may get other values as well. But if an adjacent value comes as maximum, then this is not the best choice for us. It may be a best choice for A, but it will not be a best choice for C. So what we will try to do is, we will be maintaining the top 3 slots, or you can say the maximum 3 slots. Okay, the top 3 slots. If I maintain the top 3 sized slots, like let's say it was S3, S4 and S1, then out of these top 3, at least one slot will be present which is non-adjacent to a given meeting, whatever may be the meeting. Because if a meeting is present, the maximum number of adjacent slots will only be 2. So if I maintain the maximum 3 slots, and if I compare a given meeting with all these 3 and try to see if there is any slot which can accommodate this C and is non-adjacent, then I will always pick that. Okay, but if it so happens that let's say S3 and S4 were adjacent, and S1 was non-adjacent, but the non-adjacent slot is not able to accommodate this C, then in such case we cannot do anything, but we have to just slide it either to the left or right. And in that case, what we will be doing is just add the adjacent slots S3 and S4, because in either way, wherever you slide it, it is just going to give you S3 plus S4. So that is our idea. So we will be trying to maintain the best slot options for any of the meeting. In this case, let's assume C. So we will be trying to maintain non-adjacent plus the adjacent slots. And in the worst case, you can get the maximum as the adjacent slot itself, and that is why I will be maintaining the top 3 sized slots. So only one non-adjacent slot of size which is greater than equals to C is good enough to fit this C. But still we are not maintaining the maximum, we are maintaining top 3, because 2 slots in the worst case can be adjacent. Okay, but we may require adjacent slots too, therefore we will be maintaining the top 3 slot options. So I hope this is clear. In this case, if you try to maintain the top 3 slots, then size 7 slot is present here, which is your S5 slot. So I will just number it S5, and a 5 size is present for S3, and a 3 size is present for S1. These are the top 3 slots. And out of this, if you want to place this meeting C, then you can just iterate over it and see what is the gap. The gap is 1. So check it out. If the gap is greater than equals to 1, it should be fine, but you have to check if it is adjacent or not. So S5 is not adjacent, therefore you can assign it directly to S5, and then the free time which gets created is 17 minus 9. That should be your idea. But let's try to think about how to calculate the top 3 slots. So I have already given you the start time and end time arrays, and these are all the meetings. So there are 4 meetings. Now I will be doing a dummy insertion for the last event time, because for any meeting, let's say this is meeting number 0, meeting number 1, 2, 3, I will also be taking this as meeting number 4, which starts and ends at the event time. I will be assigning the slot number with the index of the meeting present on the right hand side. So if the 0th meeting is present, the slot adjacent to it, just to the left hand side, will be marked 0. This will be marked 1. This slot will be marked 2, 3 and 4. This is how I will be maintaining the slot numbers. Now the first slot, I will be pre-filling in the top 3 as the start time for the first meeting, which is 3 minus 0, because you know the timeline always starts at 0, so that will make it 3, and the slot index is 0 because this is for the 0th meeting. And now I will start iterating from meeting number 1 and try to calculate. Now for the rest of the 2 slots in the top 3, I will be taking minus 1 values because they are unknown. Okay, now try to see for this first slot, okay, the index number 1. In this case, the slot size will be the start time at I minus the end time at I minus 1. So 8 minus 5 is 3. So the slot size is 3. Okay. Now you will be comparing this with the top 3, and the best option to compare is the smallest option, which is the third ranked item. Okay. So I'll be checking it with minus 1. If this 3 is greater than minus 1, then I will be overwriting this to 3 and the index will be put as 1. And now I will be trying to move it up and see what is its actual rank, because it is certainly greater than the third ranked item, so it was placed at third position, but maybe it is also greater than the second ranked item. In this case, if you compare 3 and minus 1, yes, 3 is greater, so do a swap. If you do a swap, it will become 3 comma 1 and this will become minus 1 comma minus 1. And again, if you compare this 3 with 3, then this 3 is not greater, so no swap will happen and you are done. This is how we will be first inserting a given slot at the last position if possible, and then we will try to percolate it up. So you will compare with the smallest, that is a third ranked item, and then we will try to percolate up and see what will be the actual rank. Now go to the next index, again find the gap 13 minus 9, which is 4, and then compare with the last item. Yes, 4 is smaller than minus 1 and the index is 2, and try to percolate up. So 4 is larger than 3, so do a swap. 4 comma 3 will come here and 3 comma 1 will go to the last. Compare 4 with 3, again 4 comma 2 comes here and 3 comma 0 goes to the last. Go to the next item, which is 17. Get the gap. 17 minus 15 is 2. If you compare with the last item, 2 is smaller than 3, so nothing is going to happen. Again check 30. 30 minus 23 is 7. 7 is greater than 3, so 7 comma 4 will be appended, and now try to percolate up. 7 is greater than 3, so 7 comma 4 comes here, 3 comma 0 comes here, right? Then 7 comma 4 will be compared with 4 comma 2. 7 comma 4 comes here, 4 comma 2 comes here. Okay, and you are done. So this is how you can find out the top 3 slots by also tracking the index where it belongs. The index is important because while choosing the assignment, we can also think about what is its index value, so that I can do non-adjacent assignment. If I can give you an example for this meeting C, which requires 2 units of time, if you compare with the first item, that means the maximum of the top 3, is this value 7 greater than equals to 2? Yes. And its index should not be 2 or 3. Okay, that means if this is the ith index, then the index here 4 should not be equals to any of the I or I plus 1. So I value being 2, is it equals to 2 or 3? No, it is equals to 4. Then that means you can do the assignment. If it was equals to any of these 2 or 3, then I will be checking with the next option. If this 4 was also greater than equals to 2, I will do the same check. And if it also do not satisfy, then I will be checking with the third option. Definitely one of these three options will be sufficing the condition, because there cannot be more than 2 adjacent slots and we are maintaining the top 3. Okay. Now if it so happens that if this was an adjacent slot and if this was an adjacent slot, then they will not be chosen. But if this was a non-adjacent slot and let's say the width was only 1 instead of 3, then this can also not accommodate it. So none of these 3 options will be chosen. And if none of the options are chosen, then the free time will be equals to whatever is the slot 2 and the slot 3's time, you just add it, and that will be equals to 17 minus 9 minus this gap. 17 minus 9 minus whatever is the meeting gap, 15 minus 13. This will give you the slot 2 size plus slot 3 size. Okay, so I hope this is clear. Now let's look at the dry run on using the rescheduling with the top 3. So in this case I have taken same example, and I have the start time, end time. I have also maintained the top 3 here. Okay, now for each of the meeting I will try to do rescheduling, and I will also track the maximum free time. So I'll be starting with the first index, which is index number 0, and in this case the meeting size will be 5 minus 3, which is 2. So I will be checking, the index is 0, right? So I will be checking with the first option, which is 7, 4. If the size is greater than 5 minus 3, which is 2, that means the size must be greater than equals to 2 to accommodate a 2 size meeting. And this index should not be equals to 0 or 1. Okay, because 0th index is this slot and the first index is the other slot, right? Okay, so this is 4. So I can do the assignment, and if I do the assignment, then the free time that gets created will be equals to whatever is the start time of the I plus 1th index, which is 8, minus whatever is the end time of the previous event, which is 0. So 8 minus 0, which is 8 minus 0, will give you 8. So the free time becomes 8 after doing the rescheduling of 8 to a non-adjacent slot. So the maximum free time will also be 8. And now we will be moving forward. Again repeat the same process for this index 1. Check out the size needed, 9 minus 8, which is 1. Again check with the top slot. So the top slot is greater than equals to 1, and the index 4 is saying it is not adjacent to the slot 1. Okay, it is not equals to 1 or 2. So you can do the assignment of this B to some non-adjacent slot, which is here, and if you do that, then the free time that is created is 13 minus 5, which is going to be 8. So this is already 8, so no update is going to happen, and we will move forward. Again for this, the gap is going to be 2. For this meeting C, the gap is going to be 2. So check it out. Again 7 is greater than equals to 2, so you can reassign at that point. And so if you can do it for a non-adjacent item, because 4 is not equals to 2 or 3, which are adjacent to this slot 2. Okay, this meeting 2 second number slot and third number slot are adjacent. This is 4, so I can do non-adjacent assignment, and so the time gap which gets created in the middle is 17 minus 9, 17 minus 9, and that will be equals to 8. So in this case free time is already 8, so no update is going to happen for this third meeting. If you do the rescheduling, what is the time? It is 23 minus 17, which is 6. Now if you check it out, 7 is greater than equals to 6, but the slot number is 4, which is adjacent to this 3. Okay, how do you know it is adjacent? It should not be equals to I or I plus 1. So since your I pointer is at 3, it is equals to 4, so this is adjacent. So check the next option. Its size is 4. Okay, so if the size is 4, then how can you schedule a 6 size meeting? And same goes for this 3. Okay, so these two cannot schedule the meeting number 3, and so you do not need to process them. Now you could not find a non-adjacent assignment for this meeting number 3. So what you got to do is, you got to slide it either to the left hand side or to the right hand side. You can just slide it. And so the free time is going to be the next meeting start time minus the previous meeting's end point, which is 30 minus 15. And from this you subtract the size of this meeting D, which is 23 minus 17. because this meeting D is not rescheduled in some other non-adjacent slot, right? So this will be 15 minus 6, which is going to be 9. And so the free time will become 9. And since this 9 is greater, maximum free time will be 9. And you are done. You don't need to process the last event because this is anyway the dummy insertion, right? So 9 will be the answer in our case. And if you have understood this, the calculation of top 3 required order of n time, and after that we are parsing over this entire array in order of n time. So both these will be added, and so the time complexity is order of n. The space complexity is only order of 1 because we are just using 3 size space for maintaining top 3, and these are the 2 variables, right? So I hope this entire approach is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the event time, start time and end time. So initially I will be doing the dummy insertion for the event time, that means the last event, and then finding out the number of events or the number of meetings. Then I will be trying to calculate the top 3. Okay, so this is the simple comparison with the last index and then percolating up as I had shown in the dry run, the same technique. And after that we will try to calculate, after rescheduling each meeting, what is the free time that we get, and we will be trying to maximize the free time and finally return the maximum free time as the result. Now this is the technique for actually finding out the free time for any rescheduled meeting. The top 3 contains the first rank, second rank and the third rank. So first I will be comparing with the last one, and if you find that the slot is large enough and the index is not equals to I or I plus 1, then we are done. If we are not done, we will check with the second slot. If we are not done, we will check with the first slot, and if nothing works out, then we know that we have to slide a given meeting either to the left or right, and so take the next start time and the previous end time and do the subtraction, and you have to deduct whatever is the meeting's width. Okay, so end time at I minus start time at I, because this will have to be subtracted because it will not be counted in the slot size. So I hope it is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.